Hello, and welcome to the FireVoxel tutorials. In this tutorial, we will introduce EdgeWave, an automatic segmentation algorithm. We will first explain the internal steps of this algorithm. Then we will demonstrate several different ways to use EdgeWave. As an example, we will measure the body fat composition on abdominal CT. EdgeWave is an automatic three-dimensional medical segmentation algorithm that uses mainly thresholding and morphology, or the shape characteristics of an image. We will start with an overview of the internal steps of this algorithm. In step 1, the original image is resampled as needed. In step 2, thresholding by image intensity is applied to roughly delineate the region that needs to be segmented, which we call the core set. The core set must enclose the segmentation target, otherwise the segmentation will fail. Step 3 is applied in some cases to detect edges or the locations of the core set where image intensity changes abruptly. In step 4, the boundary of the core set is eroded or peeled. The peel operation removes all voxels within a certain distance from the boundary, using rules applied to each voxel and its neighbors. Peeling enlarges the gaps between different regions of the image, removes small details, and breaks bridges between weakly connected areas. The thickness of the region to be removed is controlled by the peel distance, measured in voxels or millimeters. In step 5, the algorithm breaks up the peeled core set into blobs or connected components. It then determines which connected components are to be retained and which ones should be discarded. And finally, in step 6, the selected connected components are subjected to constrained growth or dilation. The grow operation adds voxels within a given distance of the ROI boundary. Any recovered voxels must still belong to the core set. The thickness of the recovered region is controlled by the grow distance, which should be larger than the peel distance. Our goal will be to segment the fat tissue on abdominal CT images and then separate the total fat into subcutaneous fat and visceral fat. We will first do it manually, using the ROI operations and then using the automatic EdgeWave segmentation tool. Let's open a document with abdominal CT images. We will first segment the total fat tissue using thresholding by signal intensity. To do this, we need to estimate the range of fat signal intensities from the image histogram. Open the ROI statistics panel by pressing F3. Here, we can narrow the range of the histogram to between 800 and 1200 units to focus on the soft tissue signal. The fat voxels form a peak between approximately 890 and 940 units. Let's note these values and close the statistics panel. Now, on the main menu, select ROI, threshold to ROI by signal interval. In the boxes for the threshold values, enter the intensity range and click OK. And here we have a new ROI layer with the segmented total fat or the total adipose tissue. This is our core set. Now we will separate the total fat into the subcutaneous fat and the visceral fat regions. First, make a copy of the threshold layer. Click Duplicate on the Layer Control panel. Now we will use the peel operation to remove voxels from the boundary of the core set. On the main menu, select ROI, Morphology, Peel. In the Peel Options panel, enter the radius of 2 millimeters. Select the 3D mode and click OK. As we can see, the boundaries of our ROI have been eroded by 2 millimeters. This is our peeled core set. Next, we will find the Maximal Connected Component. Select ROI, Maximal Connected Component 3D. And here we have a new layer with the Subcutaneous Fat, which is the Maximal Connected Component in our image. But this ROI has missing voxels as a result of the peel operation. Let's recover these missing voxels using the regular unconstrained grow operation. Select ROI, Morphology, Grow, and use the radius of 2.25 millimeters. And now, we have generated the Subcutaneous Fat ROI. To complete our segmentation and isolate visceral fat, let's use the layer operations. On the main menu, select Volume, Layer Operations. On the Layer Operations panel, check the Total Fat layer and the Subcutaneous Fat layer. To find visceral fat, we will use the logical operation of A and, not B. We will then be prompted on whether we want to keep the source operand layers. Click Yes, and then OK. Now we have segmented the visceral fat. This concludes the demonstration of the internal steps of the algorithm. The remainder of this tutorial shows how to perform segmentation automatically. Now we will use the EdgeWave tool to segment the subcutaneous fat. Let's make sure that the base image is active and the ROI layers are unchecked. Next, open the EdgeWave tool. We can use the main menu and select Segment, EdgeWave Basic, or click the EdgeWave icon on the main toolbar. This will open the EdgeWave panel, where we can set the parameters for this algorithm. Note that the default parameters are set for the segmentation of the whole brain on T1-weighted MRI. The top part of this panel contains the parameters of the core set. For the signal intensity thresholding interval, right now we have only one option to specify an absolute signal intensity range. Let's use the same thresholding interval as the one we used to segment the total fat, 890 to 940 units. For connected components, select Maximal Component Only to segment the subcutaneous fat. If we select all components, we will get the total fat segmentation. The next section contains the parameters of the peel and grow operations. For the peel distance, let's select 2 millimeters, and let's leave the grow distance at its default of 6.4 millimeters. Let's also uncheck competitive growth. The next section contains the edge constraints parameter, but we will not be using edges. Let's make sure to use the 3D mode and write the output into a new ROI layer, and click OK. And here is the EdgeWave segmentation of the subcutaneous fat. We can compare this ROI with the subcutaneous fat that we segmented earlier in this tutorial, using the ROI operations. Let's use Volume, Layer Operations, select the ROI layers that we want to compare, and use the XOR logical operation to find the differences between these two layers. As you can see, the differences between the segmentations are small and occur predominantly at the edges of the ROIs. These differences illustrate the distinction between the regular, unconstrained grow operation with the radius of 2.25 millimeters and the constrained grow operation with the radius of 6.4 millimeters. As you can see, the constrained growth produces a smoother boundary. Another way to apply EdgeWave is to use a vector ROI as a seed. This way, we will avoid the need to inspect the histogram. Instead, the selected seed will pick the signal of the structure we want to segment. Again, let's start with the base image. Click the Construct Vector ROI icon on the main toolbar and draw a vector ROI over a uniform area of the subcutaneous fat. Now, let's open the EdgeWave tool again. This time, let's define the signal intensity interval relative to the seed average, which for our ROI is 911 units. Previously, we used a thresholding interval between 890 and 940 units. This width of 50 units is roughly equal to 6% of the average seed intensity. Therefore, we can define an interval that extends from 3% below to 3% above the average seed intensity. Let's enter 0.97 and 1.03 as the relative signal intensity interval. For connected components, select Seed Components. Let's leave all the other parameters the same as before and click OK. Now we have a segmentation of the subcutaneous fat obtained with a seed ROI. To segment the visceral fat using EdgeWave and a seed ROI, activate the base layer. Draw another vector ROI in the visceral fat, or move an existing ROI, and again apply the EdgeWave segmentation. And here is the visceral fat segmented with EdgeWave and a seed ROI. FireVoxel also offers an option to segment the subcutaneous and visceral fat in one step, starting from a threshold layer. Select Segment, EdgeWave with N largest connected components, and enter 2 for the number of components. Next, you will see the already familiar EdgeWave panel. Select Maximal Component Only and click OK. And this is how the subcutaneous and visceral fat can be segmented with less effort. This concludes this brief introduction into FireVoxel's EdgeWave segmentation algorithm. EdgeWave is a versatile tool proven effective in medical image analysis. The algorithm is a key component of several of FireVoxel's processing workflows. For more information, please visit our website. Thank you.